Good afternoon. This is SER 321, Principles of Distributed Software Systems, and we're going to talk about Unit 3 today, which are build tools, particularly Ant and Make. So there's on the detailed schedule on the class page. It's also on both the Blackboard sites. So build tools, Ant and Make, and there's a couple of links to reading material. None of this is covered in the book, but to talk about Make, which is the most common build tool for C and C++, and actually Objective-C. In fact, when you do apt-get, most of the packages that you bring down, if they have to be built, lots of times they don't have to be built, but if they have to be built, they'll be built using Make after they've been configured to build the Makefile. And there's a good section actually in Nick Parlante's tutorial on C and C++. I'll go back up to the top of it as I've been accessing it. Unix programming tools, I think it's section 2, but it covers the GCC compiler, which we're using. This is actually based upon C. Make project utility and the GNU debugger. Let's see. Actually, so I should mention that last time in the video covering C, C++, and Java using the GNU debugger, I discovered that it's not as part of the standard build for Debian Wheezy, and I've added to the build page. Let's just go back and I'll show you. So in here, GDB, or excuse me, section 2 covers the Make build tool. So finish up that before we get back to GDB. I'm already into it. There it is, section 2 on Make. So it covers the Make files, the format of those files, and the stuff we're going to talk about today. And let me go back to the resources page. As I mentioned, GDB is not part of the standard build for Debian Wheezy. I've changed the instructions for setting up VirtualBox and Debian Wheezy so that it includes what you need to do in order to get GDB, and that is under the Install Optional Software section. It turns out you have to add a new repository and then update and do apt-get install GDB in order to have the GNU debugger. It's a very useful tool. You can probably get by from the course without installing it, but it's actually a good thing for you to know. And of course, there'll be some questions on the midterm exam covering it. So let's go back to the detailed schedule. And again, this is Unit 3 on build tools. Let's take a look at the PDF section. We're looking in particular at section 1D on Make and Ant. And then this is all part of the second programming assignment, in which you're to create an Ant build file project that includes an Ant build file, and it has two different programs in it, a Java program and a C++ program. Those two programs actually each have two classes. One of those classes is called Media Library. This is all described on this page. So here is the description of the media description class, and then there's also a media library class, and we're going to end up distributing the media library in let's see, not assignment 3 and assignment 4, doing it in the C++ version of it. So the methods that I'm asking you to implement are methods that will work just right for distributing it, and then creating clients of that distributed server that can create a GUI for media playback and display. So that's this is the next assignment, assignment 2, and take a look at the description of it. It's actually on both Blackboard sites, both the face-to-face and ASU Online Blackboard site. Okay, so now let's take a look at the PDF that we're interested in, and this is that PDF. You can see it's still the very first section, but we're now looking at Part D of it. And in Part D, it talks about both Ant and Make. And there's one overhead for each that kind of gives you a view of both of those. And I want to talk about that, talk about both of them today. And we'll go through the example, actually we do the Java fraction example for Ant, for the build file for Ant, and then we'll go to the C++ example, because in those that we executed last time, you'll find that there is both a Makefile and an Ant build.xml file. Okay, so for Ant is actually written in Java, and it is designed primarily for building Java projects. And in fact, Ant originally was I think now you have several choices, was for Eclipse IDE, was the build tool. Now you can use it if you want to, but there's other ones as well. And if you get into Android, Android Studio is the tool that I prefer to use for Android development. You can actually use Ant, but it actually prefers that you use a new tool called Gradle. Gradle is more script oriented. Ant, on the other hand, is based upon XML, and that XML description of what Ant should do to build and manage your project is in this build.xml file. We're going to take a look at one of those in just a minute. But in fact, the build.xml file it starts out, has a header section, a property section, where there are property definitions, and then there may be optionally some common definitions that are shared by all of the build targets, and then followed by build targets. So essentially, it's kind of a header declaration sort of a section, followed by the actions. What should I do, and what are the different things that I can do in order to manage this project or build this project? So those are called targets, and the ones that I typically show in my classes, there's a target for building, sometimes a target for executing, sometimes a target for archiving. The build is generally to compile it, so if it's C++, it'll do C++ compilation and linking, and if it's Java, then it does Java compiling into bytecode. If there's an execute target, then that target in a Java project will invoke the Java command with the appropriate arguments in order to execute the program. So for command line programs, typically that's not the case. If there's any kind of command line input, it's not a very convenient thing to use Ant to execute. It's fine to use it to build, but in fact, for windowed, for GUI, swing is what we're going to take a look at for Java. It's very convenient. And then archive, actually, it can be used for lots of different things. So we've already talked about a jar file, Java archive file, .jar. Well, the Java archive file can actually be an executable file, which is why some systems don't like jars. You may have to treat them specially when you download them. All of the jar files that are example projects for this class, none of them are executable, but in fact it's common to have an archive target in an Ant build file that will generate a jar file, and it may also generate actually executable jar files that represent in our case, it's going to be the client and the server. So let's take a look at this guy, Java fraction, and I'm going to, let's go ahead and we'll go to VirtualBox and the Debian. And the command line there, you can see I have the Java fraction already downloaded here. So let's extract it. And it will create for us this Java fraction directory. And now let's actually take a look at, I'm not going to do it in here. Let me go back, because I'll have to mess around with the font size. Let's do it. Here it is right here. I've already got it in Emacs where I want to show it to you. So here is the header for the project, and now outlined in yellow. And it's after an initial XML says that this is an XML document. The project, the project element, right? In XML, there are things called elements. And then within elements, so in this case, this is the project element. There may be attributes. So the project element has a name attribute whose value in this case is SER321, simple example of Ant to build a Java program. And then optionally, we can define a default target. So in this case, our default target is targets. It's very common for the default target to be build or compile or something like that. But in all of the examples, I think that you'll download for this class, the default target is defined to be a target called targets. So following that header information, this also brings in this case, the .NET. Oh, that may cause a problem for you. I think it's in the Ant Libs. There are an optional set of Ant tasks for building C# programs, .NET programs. And this is probably just a carryover because I've used C# on this class before. And then Apache tools.ant, and then CPP tasks. So these definitions are bringing in auxiliary tasks, which are not the standard tasks. CPP tasks are for using for doing C++ compiling, and those get used in the CPP fraction example and the other examples that we're going to do throughout the semester. So following that project header information is a set of definitions, common definitions. And in this case, there's actually these 4 different properties that are defined, and then also a path that gets defined. And the path is the compile, or is the class path that's going to be used for this Java compilation and for the Java command as well for executing. So let's take a look. I guess I'll show you a little bit about so following the project header and then the definition of properties, probably the class path ought to be above the default target, but it doesn't matter, makes no difference. Everything else in the file are target elements, and target elements define actions that can be performed. So in particular, the compilation is done in this case, the build target. So you can see the target name is build, and the primary nested component within this target element is a Java C element. And the Java C element, as you can imagine, is to compile a Java program. So its attributes describe that compile. And among them is a nested class path element, which defines the class path for doing compiling. And then down below, you can see another Java element that also has a class path. This is a class path for doing the Java command. So the class path that it refers to is the one that was defined up here, path ID compile.classPath. Now, inside of the build, there's some unusual syntax for some of the attribute values. So in particular, for the Java C, we want to compile all of the Java files that are in a given directory or all of its subdirectories. And we specify that by the attribute named source_dir, meaning source directory. And I've used a property in order to define source_dir. And that property is defined up here at the top. I've now got it highlighted. So it says that the source directory is, its value is src, meaning that if you look at the project directory, there is a folder, a subdirectory called source, and within the source directory are all of the Java files that are to be compiled. In this case, it's just fraction.java. So in fact, we can use these properties. Actually, in this example build file, the properties aren't used. We could get by without them probably, but they're typically used for things that we may want to change. So for example, if you're creating a server and that server is going to be listening to a port, a fixed port, then you may want to be able to provide that port as part of the build or execute for it. So for the fun of it, let's add a new property just to demonstrate property. So the name of the property is author, and the value is just Tim. And let's just add to the target a new echo. So whenever targets gets called, so if we say ant targets, then in fact this message will be printed out. And let's just change this. So we'll use, I can show you how a property can be used and how it can actually be defined on the command line. So the value of the author property is, and then $sub author. And now I've got to go to, so I'm not going to go back to VirtualBox. I'm going to go to this guy. Am I in the right directory? Yes. So if I do ant, since it's the default target, it's going to do targets. And you can see that, so it did targets. That's the same thing as doing ant targets. In other words, I can specify the target that I want executed in the command line. It goes in as a command line argument. And you see it should do the exact same thing. Further, on the command line, I can define I can redefine the value of a property, right? So this syntax says define -d. So call the target's target, use the target's target, and define the author property to be Joe instead of Tim. All right, so in this case, you can see instead of printing out at Tim, it overrode the value of the property in the build.xml file to use Tim or use Joe instead of Tim. All right, so I can provide on the command line new definitions for properties that are defined in the build section or in the build.xml file, or I can just use the predefined default values of them. So ant targets tells me all of the targets that I can execute. Clean, prepare, build, execute, and targets. And that is done by this echo message. Targets are clean, prepare, build, execute, and targets. So if I say ant clean, it will clean the project, deleting any temporary, in this case, class files that get created. Or if I say ant execute, let's look and see what happens when I do an execute. We can see the target, whose name is execute, has a depends clause, and it says it depends upon this name that follows, or the value of a depends attribute is the name of another target. So I cannot do an execute until after I've done a build. So if we look at the target, so what will happen when ant sees ant execute, it'll say, oh, okay, first I need to do a build. So it'll go to the target named build, which is right up above it, and it sees another depends. So it says the build depends upon preparing. So it'll go up to the prepare target, which is here, and the prepare target doesn't have any depends, and its only action is an mkdir element. Mkdir means make a directory. You can look it up in the ant documentation if you want. And the directory that it's going to be made is whatever the value of the build property is. And the build property is defined to be classes. So initially, after doing a clean, there is no classes subdirectory. Right, no classes subdirectory. So if I say ant execute, then let's just kind of trace through what happens. You can see it on the command line. Let me stretch this thing out enough so that it doesn't wrap around. So it says here's the build file that I'm using. Ant's response to ant execute is to print out the path to the build file, followed by all of the targets that are going to be executed, that are going to be evaluated in order to do an execute. So it does a prepare, and then it does a build, and then it does an execute. Remember when we went through the depends clauses for each of these different targets. So the first thing it did was prepare. That caused a make directory to occur, and the make directory made the classes directory. Next, it would do a build, which causes a Java C to occur. And that is compiling one source file into the classes directory. And then we do an execute, and that includes an echo element as well as a Java element. And the Java element executed that fraction class, which has a main method, and the result of that was to print out 1/3. Right. So in fact, you can see that ant follows the directions that are given to it by a script file or an XML file, which includes target definitions, and those targets define what it's to do for different actions or for different targets. So now you can see we have a classes directory. And if you do a listing of the classes folder directory, you see that there is a fraction.class that got created by the build target in ant build.xml and right up here under build. And now if I do ant clean and then do a listing, you see that the classes has disappeared, classes folder has disappeared. And if we go back to the build.xml, you'll see the target name clean does a delete where the directory is the $build directory. And if it doesn't, if there's a problem, in other words, if I do 2 cleans in a row, fail on error, if there's an error that's false, which means, okay, if it's already been deleted, I don't care. Right, so I think that takes care of all of those things that are in ant. Although we're going to say for right now. So part of the assignment in the next assignment, assignment 2, is to create an ant build file that will build and execute your sample program that has a library, a media library, and a media description. So you're going to do 2 different programs, one C++ program and one Java program. All right, so now let's go on. Let's go back to the PDF file, extract it, and then we looked at defining, overriding the definition of a given property. Let's go on to make. So make had its origins in Unix, Linux, as the primary build tool for C-based languages. So in particular, C++, C, Objective-C, all use primarily make as the build tool. As I said, we're not going to do that this semester. The C++ programs we're going to write, actually, we can use ant CPP tasks to avoid us having to create 2 different. So ant was actually fashioned after make with a little more legible or intelligible interface through XML. But in make, we have the same sort of a thing. We have a file called the Makefile. Why can't I do that? Because it's PDF. We have a Makefile, and that Makefile describes the targets and the dependencies and actions that are necessary to build a given target or a given program. So the Makefile consists of variable definitions followed by rules. So an example of a variable definition is defining the variable capc, which is the C compiler. So in this case, if I say capc equals G++, and then I say C flags, so these are all the switches that are to be used in doing a compile. C flag stands for compile flags, and LD flags stands for load or link flags. So in this case, -G and fine-tune the debug instrumentation that's necessary to the G debugger, the GNU debugger. And then the other LD flag is to use the library called standard C++ library. All right, so there's an example of 3 different variables that get defined in the variable definition section of a Makefile. And then there's a set of rules. And the rules have the following form. In order to get the target fraction.o, I must first have fraction.hpp and fraction.cpp. All right, and then so that's the dependency part. So rules have the name of the rule. In this case, the name of the rule is fraction.o, what I want to create. And the dependency is fraction.hpp and fraction.cpp. And then the rule, the action for obtaining the target, fraction.o, is to use $CC with the $C flags. All right, so in other words, expand the environment variable, or expand the variable CC, which is G++, expand C flags, which are -G-GDB, -C stands for just compile, and then apply those to fraction.hpp and fraction.cpp. Right, so this rule says that the object file fraction.o must be rebuilt whenever fractions header file or fractions implementation file change, right, when there's an update in the timestamp for them, and it gives the command for compiling it to get fraction.o. So let's take a look. So there is a Makefile, and we'll do this one here. So let's do cd./cpp fraction. And you can see, so this is what you get when you extract cpp fraction.jar. You get this, and there is a build script, which is nothing more than a text file that contains the commands for compiling it, if you were to do it from the command line. A build.xml, which means that you can ant compile this project. And there's also a Makefile, which allows you to use make in order to build, and it's not for execution, it's just for building, and a readme.txt file, which explains all the stuff I'm explaining. The live directory has in it an anttasks.jar. So you will need to take this either for Java fraction or CPP fraction. I think the live directory is in both of them. If you do jar tvf, which says don't extract, but show me the contents of the file, anttasks lib anttasks, you'll see that it includes a .ant directory and then a lib folder within it, which has ant-contrib, ant.net, and CPP tasks. So what you need to do is to copy this anttasks.jar. This is in the readme.txt file that explains how to do this. Copy anttasks.jar to your home directory. Change your home directory and extract that. It will create the .ant subfolder or subdirectory from your home directory, and within it a lib subdirectory that has these jar files. So these are all classes. So just for the fun of it, I'll just extract it here. So now I've created a .ant, LA, so dot is a hidden file, cd.ant. So now there's a hidden folder ant, and within it is a lib directory, and within it are jar files, right? So the archive in the lib directory anttasks.jar is a jar file that contains other jar files, and jar tvf cpptasks.jar shows me all the stuff that's in the CPP tasks, and you'll see that these are all class files. So it's very common in Java. Java was designed so that you could distribute libraries of things that you wanted other people to be able to use by means of a jar file, which contains all the classes. So you can add to your class path not only a directory where it will find classes, but you can also add to your path a class file, a jar file that contains classes that may be used in building your Java program. So in particular, since ant is written in Java, its class path needs to be extended when it encounters, we had it up here, when it encounters, for example, XML namespace CPP tasks, antlib net.sf.antcontrib.cpp tasks, it looks for the classes in net.sf.antcontrib.cpp tasks, looks for all of those classes, and as a Java program, it goes and tries to load all of those classes in that package. If this net, SF, ant, contrib, CPP tasks, types, all of the classes within there are not available, then in fact it will cause an error. So in order to do CPP compiles, C++ compiles in Ant, your Ant's class path has to have this jar file contained in it. And that's what happens if you follow the readme.txt file, and kind of an explanation of what it is all about. So I'm going to get back out of here. So I went back up two directories, rm-rf.ant. That's to get rid of the directory that I just created. And now let's go back to the fractions. And let's do, so there's three different ways to build this. One of them is by using the build script. So what I just did when I did /build script was to execute this build script. This says it is a script, meaning it's a bash script, and anything that begins with a pound sign is a comment. G++-G-G debugger, compile, source fraction.cpp, and source main.cpp. Right, so you don't have to specify the header files in a G++ or C++ command line compile. And then after this didn't do the link phase, it only did the compile phase, it created the O files. So now you can see I have fraction.o and main.o. There's a main CPP in the source subdirectory and a fraction CPP. So they've been compiled to create these object files. And then G++-G debugger, main.o, fraction.o, add to that the library's lib standard C++, and create the executable, -o is the output, create the executable fraction, will cause it to execute. Right? Fraction 0/1 and 1/3 before it gets initialized and after it's been initialized. So now I'm going to use make, because it does the same thing, make clean. We'll look at the Makefile, but make clean, there is an action in make for cleaning, in the Makefile for cleaning, and we just invoke that action. So these intermediate build files, meaning the executable and the .o files, have now been removed. Right? So the build script is one way of doing it. Second way of doing it is by using make. And make just did the same two commands that we just did. So the default target for make is to make fraction, the executable fraction. In order to make that, there's a dependency that says, first I have to do a compile of those two files, and then I have to do a link. So now we have the exact same thing, fraction. When we execute it, we get the same thing, make. And that got rid of it. So now let's go and take a look at its Makefile. So here is the Makefile that is in that project directory. I'm actually looking at the version of it that's on my OS X instead of inside of the Debian Linux. But you can see, in fact, the exact same CC environment variable is being defined, C flags is being defined, LD flags, exact same definition that was on the slide. There's also a source directory, and then program. The name of the program is fraction. The headers and the sources, it's very common. The implementation is commonly called the sources. So now the different targets. This actually gives the object files that are available. And in order to make the program, which is fraction, what we have to have is dependency, or the objects. And the object files are .cpp equals .o, right? So this is nothing more than a replacement. It says take all of the source files and replace cpp for .o. So fraction, or main.o and fraction.o are the names of the objects. So getting a fraction depends upon having fraction.o and main.o, is what this line says. Having the fraction target, or having the fraction executable, requires first getting main.o and fraction.o, and the action for obtaining fraction from those .o files is G++, right, fraction.o, main.o, where the output is -o is fraction, and the link flags expanded -g, -g, gdebugger, and -lib, standard lib C++. Right, so that tells us how to get fraction. And here are the two rules for constructing main.o and then fraction.o. Right, and then a rule for cleaning. And there's no dependency for the clean action, and its action, excuse me, for the clean target, its action is to remove, force the removal of core, if there's a core dump, fraction, and the .o files. And then the GCH is a symbol table file that can be created with the -G switch. Right? So there's an example of a Makefile. If that's a little confusing for you, actually you should understand it. I'll have some questions about the format of rules on the midterm exam, and some sample rules. But in fact, we're not going to use Make extensively. Instead, we're going to use Java. And let's take a look while we're here in the same directory, because there are some differences with the build.xml. So this build.xml will build both the Java target and the C++, the Java program and the C++ program. And the way that that's done is by expanding on the prepare to determine whether I'm on a Linux host or on a Mac OS X host, I think is the Nope, this is just showing you an if-then. That's all it is. So the prepare checks to see if the environment variable username is defined. And if it is, then it echoes the message detected the username, and environment.user echo the message detected user is environment.user. So it looks to see whether the USER environment variable is set in the environment, or the username environment variable, two different depending upon Linux or Mac OS X. And then it echoes out the name of the host name, just to show you some other kinds of things that you can do in an ant build file. So the build for CPP fraction is it doesn't do Java, it just does C++, contrary to what I said a couple minutes ago. Uses the CPP tasks CC element, C compile, where in fact it's going to be creating a C++, and it says the output type is executable. It's a console program that's being built. The out file is dist directory is the bin directory, the fraction executable. The object directory is where the .o files are to be placed, and the lib set is user lib. Libs, right? So this is saying go to user lib to find the library lib standard C++. Actually, standard C++ is, yeah, it might be in user lib. And the file set, actually it has a set of a search path for libraries that are already built into it, which already includes user lib anyway. We use the lib set if we have built, we'll see that later on in the semester, where we've built a special package that is to be imported into our C++ program, right? And then the file set is from the source directory, which is fraction.cpp and main.cpp. So we can build this program either with ant or with make. So I think I did make clean. So let's do ant execute. So you can see in this case, when I do ant execute in the prepare task, it says that the home is user Lindquist, and the created a bin directory, an object directory. Detected user is Lindquist. It is a Linux system running on the architecture 386, and the host version is 3.2. This is the version of Linux that I have installed, and it tells me the base directory. So it compiled it and then and linked it and then ran it. So just for the fun of it, let's go back to Mac OS X and cd.c++ fraction and ant execute. And if we compare the output from the two different systems, you can see actually that prepare task. So on on Mac OS X, it found that my home directory is users Lindquist. Actually, it uses a different part of the if. I think on one system it's user, and the other one it's username. And then it indicates that the host name is Mac OS X. It's an x686 64-bit Intel, and the version of OS X is 10.10.5. Right, very different than the prepare output from up above. So it looks at the environment to find out information about the specific system, which can actually be very useful. So why is that important, and why is this in a build file for C++? Because in C++, the command line for compiling is system dependent. And some of the example programs, since I developed them on my OS X program but want them all to run on Debian Linux, the compile command for C++ can be different on those two different systems. So I use the prepare task. You'll see it in some of the build.xmls later on in the course when we actually get to some of the distributed programs. Okay, so I think if I go back to this guy, we have covered everything that's in here. Yes. So I'm not going to talk about GNU step, and I'm also not going to talk. You're more than welcome to. There is a command prompt for Windows that has some of the same capabilities that exist within Linux and OS X, but they aren't. It's not by any stretch the same thing as the Bash command prompt. So I'm going to leave it at that for today. So again, this has been the section Unit 3 on Build Tools, Ant, and Make. Right. Very good. And the next version, or the next video that we'll be going through, will be serialization, and that is in the next unit, Unit 4. Okay.